Hello ladies and gentlemen, this is Mr. Santoro again. Welcome to the third screencast lesson of the school year. In today's lesson we'll be talking about restricted domains. So as part of this, there are a couple of basic things that you have to remember as we go through the lesson here today. Okay. Number one, you cannot divide by zero. So if we're looking at anything with a fraction, you cannot have a zero in your denominator. And also, we can't have a negative under the radical sign. Everything we're going to be doing is real numbers, not imaginary or complex numbers. So with that in mind, let's take a look at the first case that we have to look at with restricted domains. So if we have a fraction, for instance, f of x equals x plus 8 over x minus 6, any value that makes the denominator 0 has to be excluded from the domain, since we can't divide by 0. Okay. So what we do therefore is we take the denominator of x minus 6 and set it equal to 0. Then we solve that. And we find out that when x is 6, our denominator is 0. So we have to exclude that from the domain of the function. So if we were to write it in set builder notation, we would say that all values of x such that x is not equal to 6. Or we could put it in interval notation where x is less than 6 and x is greater than 6, but x does not equal 6. Let's look at another example. F of x equals x plus 7 over x squared minus 5x. Again, nobody cares if the numerator is 0. We care that the denominator can't be 0 because you can't divide by 0. So we take the denominator of x squared minus 5x, set it equal to 0. We factor it. Greatest common factor is x. So you have x times x minus 5. You set each factor equal to 0. X is equal to 0. X minus 5 is equal to 0. So now we have two values of x that have to be excluded from the domain. X is 0 and x equals 5. So if we were to write that in set builder notation, we'd say that all values of x such that x is not equal to 0 and x is not equal to 5. We could put it in interval notation, which is what I have here. So every value from negative infinity to 0 is valid. Skipping over 0, everything from greater than 0 to less than 5. And then skipping over 5, everything greater than 5. Let's look at the next case. Next case is we have a radical as our function. So since we are not dealing with complex or imaginary numbers, what's under the radical sign has got to be greater than or equal to 0. 0 is acceptable in this case because it's not a denominator. So when we have a function that's not a fraction, you take what's under the radical sign and you set it equal to greater than or equal to 0. Then you solve it. You find out that x is greater than or equal to negative 5. Again, set builder notation and interval notation. So every value from negative 5 to positive infinity works for this function. Let's look at another example. F of x is equal to the square root of 2x minus 1. So we take the 2x minus 1 and you set it greater than or equal to 0. You solve that and you find out that x is greater than or equal to a half. That's what it is in set builder notation, and that's what it is in interval notation. There's a bracket, 1/2, comma, infinity, and infinity is always followed or preceded by a parenthesis, not a bracket. So that's so far two different ways to restrict the domain. If you have an algebraic expression in your denominator, set it equal to 0 and solve it. That value gets excluded from the domain. If your function is a radical, you set what's under the radical sign greater than or equal to 0 and solve that, and whatever value you get there, that's how you restrict that domain. Now let's look at the third instance. The third instance is the radicals in the denominator. So this is a combination of the first two instances. We can't have a negative sign under the radical sign, a negative value under the radical sign. And then because it's a denominator, you can't have a 0 either. So when you have the instance with a radical as the denominator of a fraction, you're going to take what's under the radical sign and set it to greater than 0. So when we solve this, we find out that every value of x greater than 5 works for this. So there it is in set builder notation. All values of x such that x is greater than 5. So let's take a look at another example. H of x is equal to 1 over the square root of x plus 3. So we take the x plus 3 greater than 0, solve it. X has got to be greater than negative 3. So in set builder notation, it's all values of x such that x is greater than negative 3. And here it is in interval notation. Parenthesis, negative 3, comma, infinity, parenthesis. Okay. So this is the third instance. Let's take a look at two practice questions that you also have on your sheet. Let's find the domain of each using interval notation. Example 1, f of x is equal to the square root of 3x minus 6. So in that instance, we'll take the 3x minus 6, set it greater than or equal to 0, solve it. So we know that all values of x such that x is greater than 2, greater than or equal to 2, will be valid values for this function. So here it is in interval notation, which is what the problem called for. Bracket 2 comma infinity and parenthesis. If we look at example 2, we're only concerning ourselves with the denominator. Since it's a fraction, that's all we really care about. We're not looking for any value that will cause our denominator to be a 0. So we set our denominator equal to 0. 2x minus 5 is equal to 0. And we solve that, and we find out that x is equal to 5 halves. So when x is 5 halves, our denominator is 0. So we need to restrict that domain. And this is how we would do it in interval notation. From negative infinity to 5 halves, but not 5 halves. Skipping over 5 halves, we have greater than 5 halves to positive infinity. So if you need, replay the video again. Bring any questions to class. I'll see everyone. We'll entertain any questions about today's lesson. And then we're going to be doing some practice problems.